Okay, we are doing lesson 6.4, example 1, and it can be found on page 268. So today we're going to be comparing linear and nonlinear functions. Everything you see is a function. It is a function. But we want to know, is it a linear function? Does it make a straight line? Or is it a nonlinear function? Is it a curved line? So let's take a look. We have an XY table. This is a vertical table. 3, 4, 5, 6. 1, 2, 3, 4. So we want to know, is this a linear or nonlinear function? It is a function. But we want to know, is it linear? Does it form a straight line or nonlinear? Does it form a curved line? So the way we do that, and we've already touched upon this, we're going to look for a constant. We're looking at the patterns, and we're looking for a constant pattern. So let's take a look at our x's. 3 to 4, plus 1, plus 1, plus 1. So my x, we have a constant change, right? Or a constant pattern. Plus 1, plus 1, plus 1. This is a constant change. It's increasing by 1. Let's take a look at our y's. Oh, look at that. Our y, we have a constant rate of change here. It's constant. Everything increases by 1. So I don't know if you remember from a few weeks ago, rate of change is also known as slope, right? The rate of change and the slope are the same thing. And that's a change in y over the change in x. So my change in y is constant. It's plus 1. My change in x is constant. It's plus 1. So I have a rate of change or a slope, right? 1 over 1. These are constant. So as our x increases, that means it's getting bigger, by 1, the y increases by 1. So here we can see, we're looking at this and this, our rate of change or our slope is constant. It's not changing. It's all plus 1. Therefore, this is a linear function. That means if you graph these ordered pairs, it's going to be a straight line. Okay, let's do another example. This time we have a horizontal table. So this time we have a horizontal table, and this is a function. We want to know, is it a linear function or a nonlinear function? When we graph this, is it going to be a straight line or a curved line? So we're going to do the same thing. We need to look for a constant change or a constant pattern. So 3 to 6 is plus 3, plus 3, plus 3. So let's take a look at our y's. Minus 8, minus 8, minus 8. So our rate of change or our slope is the change in y over the change in x. And we have a constant change here. Our change in x, this is constant. Plus 3, plus 3, plus 3. Our change in y, this is constant. Minus 8, minus 8, minus 8. So our change in y is constant. Our change in x is constant. Therefore, we have a constant rate of change or slope. So with that being said, as our x is increasing, as our x increases by 3, the y, now this is negative, so it decreases by 8. Now, since we have a constant rate of change, we have a constant rate of change or slope. Therefore, this is a linear function. If you graph these points, it will be a straight line. Now, when we talk about a constant rate of change, our x's need to be constant and our y's need to be constant. But the x and the y do not have to be the same. My x and my y do not have to be the same. As you can see here, my x is increasing, my y is decreasing. And this is increasing by 3 and decreasing by 8. So my x and y are not the same. But all of my x's are the same. And all of my y's are the same. So that's what we need. We need a constant change for the x's and a constant change for the y's. So if we have a constant rate of change, then it's a linear function. Okay, well, that's fine and dandy. Let's talk about what a nonlinear function looks like. Okay, let's talk about what a nonlinear function looks like. So let's create another table. And in this case, we're going to use a vertical table. It doesn't matter if it's vertical or horizontal. Now, this is a function. We want to know, is it a linear function or a nonlinear function? So we need to look at our change. So let's take a look at x plus 3 plus 3 plus 3. So far, looking good. Let's take a look at our y plus 3. Whoa. Plus 5. Whoa. Plus 7. Now, I definitely see a pattern here, but my change is not constant. It's changing. I have a 3, a 5, and a 7. Those are all different. It is not constant. So when we're talking about our rate of change or our slope, that's the change in y over the change in x. We'll take a look at our change in y. Do we use plus 3 or plus 5 or plus 7? I don't know. I don't know which one we're going to use. Now, this is constant. They're all plus 3. So when I look at this, I do not have a constant rate of change. So that we do not have, there isn't a constant rate of change. Does not have a constant rate of change. My change in y is not constant. It's not the same. So as our x increases by 3, the y increases by 3, 5, 7, by different amounts. So here, this is constant, but different amounts is not constant. We do not have a constant rate of change. Therefore, this is a nonlinear function. It's a function, but when you graph these points, they're going to curve. It's not a straight line. They're going to curve. So that's what we're doing today. You're going to be given tables, and you have to look at the change in x and the change in y. If it's a constant change, it's linear. If it is not a constant change, it is non-linear.